10 people are to be chosen to receive concert tickets from a group of 8 men and 6 women. Find the number of ways the 10 people can be chosen if there's going to be 6 men and 4 women. So basically, from the 8 men, we need to choose 6, and from the 6 women, we need to choose 4. So that's quite a simple calculation. And so that's 8C6 multiplied by 6C4. That gives me 420. The group of 8 men and 6 women contains a man and his wife. Find the number of different ways the 10 people can be chosen if both the man and his wife are chosen or neither of them is chosen. Now note that we're not giving particular numbers to men and women now. That was only in part 1. And so altogether, these are 14 people. So let's suppose that they're both chosen. Then there are 12 remaining people to give the 8 remaining tickets. If they're not chosen, there are 12 remaining people who have to get all 10 tickets. So we have 12, choose 8, so that's 495. And then we have 12 choose 10, and that's 66. And we need to add those. So add 495 gives me 561. Okay, moving on to the next part of the question. So Freddie has forgotten the 6-digit code he uses to lock his briefcase. He knows that he did not repeat any digit and that he did not start his code with a 0. Find the number of 6-digit numbers he could have chosen. So we've got 0 to 9 is 10 digits. And 6-digit code. We know he didn't start with a 0, so there's only 9 choices here, but then we can reintroduce the 0. So 9, 8, 7, 6, 5. So we've got 9 times 9 times 8 times 7 times 6 times 5. So 136,080. Freddie also remembers that his 6-digit code is divisible by 5. Okay, there's going to be some cases here. So if we start with a 5, there's only one choice here. And there's only then one choice here as well, because it must end in a 0 if that's the case. So we've already used 2 of the 10 digits, so then we've got 8, 7, 6, 5. Now, the other case here is not 5, and of course we know it's not 0. We were already told that. So we could have 0 or 5 here. And so there's 2 choices there. So we've used 1 digit at the end here. We're not allowed to have the 0 here. So we've used a 0 or 5 there. So there's actually only 8 choices to start, because he can't use the 5, and we know he's not using the 0 either at the beginning. But then we've only used 2 digits, so we've got 8 again, and then 7, 6, 5. And those should be the only 2 cases, so we need to work those out and add them up. So I've got 8 times 7 times 6 times 5. That's 1,680. And then here I've got 8 times 8 times 7 times 6 times 5 times 2, which was 26,880. So I need to add the 1680 onto that. 28,560. So Freddie decides, which is not surprising considering how many he would have to try, he decides to choose a new 6-digit code for his briefcase once he's opened it. He plans to have the 6-digit number divisible by 2 and greater than 600,000. Okay, so we've got some cases here that we could use. So 1, 2, 3, 4, 5, 6. So let's suppose he decides to start with a 6. Then the choices he has here are 0, 2, 4, and 8. So he's got 4 choices there. Now he's already chosen 2 of them, 2 of the numbers, so there's 8 digits left, 7, 6, 5. And exactly the same argument happens if we use the 8 here. So we could say 6 or 8 and just change that to a 2. His other choice is 7 or 9 here, so there's 2 choices. But that means in here you can have 0, 2, 4, 6 or 8, and that means he's got 5 choices at this end. He's used 2 digits, so that's 8, 7, 6, 5. And so we just need to work those out and add them up, because I think we've covered all of the cases there. So, what have we got? 2 times, not 22, 2 times 8 times 7 times 6 times 5 times 4. So that's 13,440. And then we've got 2 times 8 times 7 times 6 times 5 times 5, 16,800. We'll add those up. So add 1, 3, 4, 4, 0 gives me 3240.